Uh, Good Friday, everyone. My name is CJ. I'm a CEO and co-founder of StreamNative. StreamNative is a company that offering a cloud-native event streaming platform powered by Pulsar. And I'm also the PMC member of Pulsar and PMC chair of BookKeeper. So I have been doing a lot of hands-on sessions about Pulsar and BookKeeper. And TGI Pulsar. It's named as Thank God It's Pulsar. It's a weekly live stream that talking about Pulsar in its ecosystem, and we live stream everything about Pulsar in its ecosystem on Friday, and to hope that give everyone a good idea about the knowledges about the component of the whole Pulsar and its ecosystem. And today I'm going to start talking about setting up a production-ready Pulsar cluster. And one of the most important thing to setting up a production-ready cluster is to secure every component, to secure all the connections between the components within the Pulsar cluster. So I'm going to talk about this topic and starting from TLS. And let's get started. As usual, I'm going to share this link to the YouTube live streaming chat, and so everyone can just check out this markdown and about what other content I'm going to talk about today. So let's get started to go through what's happening in Pulsar community this week. Start with a week in review. And I think the most exciting thing this week is StreamNative in OVH Cloud open source the corporate work that we have been working for close to half a year is to bring in Kafka native Kafka protocol support to Pulsar through a project called KOP. Uh, it's short for Kafka on Pulsar. So what KOP it is, it's a protocol handler that bring in native Kafka protocol support to Pulsar. So it's a protocol handler means you don't need to set up a new component. You just if you already have your Pulsar cluster up running, the class you already have your broker, you can just download the KOP protocol handler and install the handler to broker. So the handler would be acting as a new protocol running as part of your broker. So your broker don't so you don't need to have additional components. You would have you are able to configure your broker to speak both Parser protocol and Kafka protocol. So as this diagrams as this diagram you can see, it's actually just adding additional components that highlight in green. That is the component we are adding, and so it leverage all the fundamental components that Pulsar already provide, like all these load balancer, geolocation, manage ledger. So you don't need to worry about like the data availability, consistency, and how to replicate data between systems. So it actually provides a mechanism for you to support both Kafka application and Pulsar application using one infrastructure. And you can check out and download a Pulsar handler and install to your existing Pulsar cluster and try it out. And if you are interested in learning more about details, StreamNative and OVH Cloud are co-hosting a webinar on the coming Tuesday, and there's a link up. You can register yourself through this form, and you will get an invitation about the Zoom link and as well as the information for you to join the webinar. So if you're interested in this topic, save your spot today, and looking forward to see you online on the coming Tuesday. Okay, so that's what's happening in the most exciting things happening in Pulsar community this week, and as well as the community is also voting the first release of Pulsar native Go client. So if you're using Go client, go to Pulsar mailing list and vote this release. And the 2.51 release is also ongoing, and there's one more issue to be merged. After that, we are going to start the release for 2.5.1. Okay, that's all about the what happened in Puzzle community this week, and let's go on to the actual show today. Uh, so the show today is when you're running a Puzzle cluster on production, and especially when you're running a cluster on Kubernetes, and you want to expose the cluster to outside of the Kubernetes network to be offering this cluster to be used by your application running publicly. So you have to make sure your component, your cluster is actually enable TLS to encrypt all the traffic going through Pulsar. So I think that is the kind of a basic requirement for running a Pulsar cluster on cloud on production. But in some of the extreme case, you have to considering secure every component within a parser cluster. For example, the connection between proxy and broker, and the connection between broker and bookies, and also the connection between proxy, broker, and bookies with Zookeeper. So that is something you have to making sure you're able to configure to enable TLS on individual components within the cluster. So that is the whole thing about securing. The first thing you need to do is securing the cluster with TLS. And so let's start a bit from a basic concept about TLS. I think I'm also not an expert about this TLS, but I have some basic idea, and I find there's a lot of information that out on internet. So you can Google it and read a lot of articles. And I believe we try our best to talk about to give an overview about TLS in Pulsar documentation as well. And so hope that those materials you can use to learn a bit more about TLS. But to get started with some basic idea, what TLS is a kind of enhanced version of SSL. And what it does is basically provide data encryption and data integrity and authentication. So in a lot of cases, TLS can be used for both data encryption and authentication. But sometimes if you try to combine both data encryption and authentication in same talk in some same concept, you would it would make things a bit hard to explain. So in this show, I would only talk about the TLS encryption, and to leave the authentication as aside, because when you're talking about authentication, In Pulsar, you have different authentication provider. You can configure mutual TLS as your authentication provider. You can also uh, configure JSON Web Token as an authentication provider. So not everyone would use TLS as a mutual authentication, but most of people would use TLS for data encryption. So that is the first step. Everyone should kind of try to separate data encryption from mutual authentication. For encryption perspective, you just need to make sure you're using TLS for encryption, but you can still using different authentication provider for authentication. So in like to using a simple language or sentence to describe what is TLS. TLS is basically is a public it's a encryption mechanism that is using uh, some symmetrical or asymmetrical mechanism to encrypt the data, transforming between a client and server. But nowadays, most of the people are kind of using public in private key as the encryption mechanism. And to understanding how TLS works could help you understanding how to configure or how to enable TLS on individual component. So uh, in TLS is using public and private key for encryption. And the public key means the key is able to make public available to everyone. And so the client can uh, use this public key to identify what entity or what person does this key claim. So if you're receiving a key, then you need to know, okay, if this key belongs to this server or if this key belongs to a bank. So, and how do you know if this key belongs to a person or belong to an entity? The answer in TLS is you need to use a digital certificate. How to uh, kind of how to explain what does a digital certificate means? A certificate means it's similar as your passport today. So everyone has a passport, and government or like any uh, country is using a passport to identify a person. So a passport is basically it's establish a link between a photo with a person. So does the digital certificate. A digital certificate basically it's it's create a link between a key and an identity, an entity. The entity can be a business, can be a domain name, or can be a component. And similar as the passport is issued by a trust authority. Usually, it's the passport office that for each country. And in TLS, digital certificate is basically issued by a trust third party. It's usually a certificate authority. Like for example, the most popular one is the Let's Encrypt. Let's Encrypt is a trust third party that can issue certificate. So a digital certificate provides a convenient way to dispute the trusted public encrypt keys. Uh, so in the whole conversation is in the TLS, you need to have trust authority that is well known as CA, that is be able to issue a certificate for a given entity, a given domain name, a given a component name. So the way how it works is if you want to set up a public available service, you need to obtain a digital certificate from a well-known or well-recognized certificate authority, which called CA. And in order to obtain the certificate, is you need to issue a certificate request. And once you issue the certificate request, and the certificate authority will do some checks, and it will send you back with back the keys that enclosed in the certificate. Then you can dispute this certificate to your service, and the certificate can be trusted by your client, and the client can use the trust certificate to connect to your service. So that is the way how a basic TLS encryption works. As as the as what I'm trying to expand here is in the TLS encryption, what you need to care about is you need to care about a certificate authority, which is the CA. And you can use a well-known certificate authority to generate the certificate. For some development and testing purpose, you can create a certificate that locally without external approval, which is commonly known as self-signed certificate. So once you have the CA, then you can issue or create a certificate request to sign them using the CA, and this would uh, you basically generating a key for your service, and you use the CA to sign this key to generating a server certificate. And the server certificate is a public uh, certificate that you can distribute to for your client. In some of the case, uh, people when some of the service when they config these CA keys in certificate, they usually use key store in trust store, because key store in trust store can be used for managing keys for different entities, and managing the trust certificates for different entities. So it's more relevant when you config TLS for mutual authentication, because if you want to set up TLS for mutual authentication, you need to issue uh, certificates for different entity, and this has to be done in both client side and in the server side. So with that being said, both the trust store and the key store would be used for storing the trust in the keys. And then it might vary between the server side components and the client side component. On the server side, the trust store is usually storing the certificates for the trusted client. So the server would use the trust store to verify the connecting to different clients are the trusted clients. And the key store um, is usually storing the private key in the public key of the server. The private key and the public key are kind of used for generating the certificate. And similarly, in the client side, the trust store is used for storing all the certificates for the trusted server. So it will make sure when it does the TLS handshake, it's able to verify I'm connecting to a trust server. And the key store is used for storing the private key and public key for the client. So I mentioned this key store and trust store here is if you want to config TLS for BookKeeper and Zookeeper, you have to going into configuring key store in trust store, because that is the way how BookKeeper and Zookeeper enable TLS for encryption and authentication. So hope that give you a kind of a basic idea about what when you enable uh, uh, encryption for Pulsar, you have to know what are the kind of basic concepts and what do you need to do when you enable um, a TLS encryption for different components. So if you go to Pulsar documentation, you're able to see under security there's a chapter called transport encryption using TLS. So this is the chapter that is talking about how to create uh, how to enable TLS encryption for broker in proxy. So if you looking into the structure of this document, you can see the um, in order to enable TLS encryption, you have to first you need to have a CA. But most of the case, you can obtain so you can use a third-party trust authority, which is a public well-known CA. Like for example, Let's Encrypt is one of the well-known CA. And if you don't have if you don't want for development of testing purpose, you don't want to obtain the CA from a third party trust CA, you can generate the CA locally. And in order to generate CA, there's a bunch of the instruction. The most important things is you need, when you're generating a CA, you basically generate a key. That is the private key. And you will use this private key to issue um, uh, certificate for different entity, like for your broker, for your client, and for your proxy for your function. So that is the private key, and that private key is super important. You need to make sure you are storing the key in a secure place and it's not leaked to public. And the other one is you you were generating the public certificate, and that is the public certificate is the certificate of this CA, and you can dispute this public certificate as a trust certificate to all the parties. So these parties would use this public certificate to connect to the service config using this CA. So that is the two things. So that is the if you want to enable TLS, you need to get a CA. If you already have a third party public CA, you don't need to create this. But for developing or testing purpose, if you want to testing the whole process, the first thing you need to create a CA, and you just need to create once. And you can use the CA to generating different server certificate for different components. So once you have the CA, the next thing is you need to create a server certificate for individual components. So you need to use that certificate to identify individual components. Like for example, if you have brokers, you need to have brokers. And if you have a proxy, you want to expose this proxy to your client with TLS, then you need to have a certificate for proxy. But sometimes you might just want to say, I would just want to create one server side or server certificate for both broker and proxy, and that is fine. And you can just generating one certificate and then use that for both broker and proxy. But to kind of capture who is connecting to which component, it's recommend to you just generating different server certificate for different component. It's good for auditing perspective. So in order to generating a server certificate, it's very similar. You need to generate a key for this component, and this key will be only used by this component, and then you're generating a certificate to identify this component. So until this point, then you would have a public CA certificate, and then you would have a key and also a certificate for individual components. And then you can take these three items to config the to enable TLS for a given component. And so that is kind of you generating the certificate for identify different components. And in order for your client to connecting to the component you just enable TLS, what you need to do is you just distribute this CA cert to your client, and then your client can config the CA cert to connecting to the component. For example, in this, in if you using the Pulsar CLI, you can config in the CLI. There's a config called client conf. You can config that. You can you basically distribute the CA public cert to your client, and your client can use this cert file to config. I want to use this cert file to connecting to my components that is certificate by this CA. So that is the way how TLS can be configured. And at this point, we don't kind of generating a client certificate. It's because the client-side certificate is more relevant when you want to enable mutual TLS. If you just want to enable TLS for data encryption, the server-side certificate is the most relevant items, and hence that is kind of the components or the settings you need to take care when you want to enable TLS encryption for a given component. So I think at this point you have a basic idea. So for configuring a given component, I need to have first I have a CA, and for the server side, I need a server certificate. And in order to generate the server certificate, I need a private key, and I sign this private key using the CA. And once the CA is signed, it will generating a server side certificate. And I can use this to config a server side component. And after that, I will just distribute the CA to my client, and my client can use that CA to connecting to my server. So that is the basic idea. And the most challenging part when it applies to Pulsar, and what I have been seeing is when people try to enable TLS on Pulsar, the most challenging thing is not like how you config TLS to talk to how you enable TLS on your broker or on your proxy for your client, because that is only the first step. You kind of securing the traffic between client in your broker. But the most challenging thing is actually happening if you want to having all your connections within your cluster to be TLS encrypt. So basically, you don't want any connection is non TLS encrypt. That is the most challenging part. And hence, I want to kind of uh, showing a diagram that is hope that diagram can help people understanding the whole uh, network connectivities and also network settings when they want to enable TLS for between components. So this is kind of a diagram that I might be using this diagram before when I talking about the how to set up a Pulsar cluster. Setting a Pulsar cluster, you need to understanding the network connectivities between each component. Similarly, if you want to configure TLS encryption for the whole cluster, you also need to understanding the network connectivities between each component. And in future, if you want to enable authentication, that you also need to use this diagram to understanding how you should configure authentications. So in this diagram, basically I divide this into two parts. One is the core part, which is the core component of a Pulsar cluster. So for the complete picture, I put every component into this diagram, but sometimes you might not enabling you might not have proxy, you might not have function worker. You can just ignore those components. There's no problem. Uh, and in the right side, I config some of the monitoring components like people use Prometheus for collecting metrics, using Grafana for visualizing the metrics into a dashboard. You are configuring Pulsar Manager to managing a cluster. So those kind of components might be interacting with Pulsar cluster. So if you enable TLS on those components, then you have to also thinking about how you want to configure TLS for those monitoring components as well. So that is the first thing. And let's go through this a bit. Mm, to give you a quick kind of overview here is your clients need to connecting to proxy. And proxy, it depends on how you configuring the discovery. You might need to connect to Zookeeper, but you might not. Uh, proxy would talk to broker. If you config function worker running outside the broker, the proxy also might also talk to function worker as well. And function worker might talk to broker. And broker would have its inter-broker communication. Like for example, if you do geo-replication, or if you're running some of the admin requests might be doing interaction with other brokers as well. And the broker need to talk to bookie, and proxy, broker, and bookie might talk to Zookeeper. So that is the kind of a basic diagram. If you config Pulsar Manager and Pulsar Manager need to talk to brokers. So hope that give you a basic idea. So let's get started by starting from broker, because in most of the case, the broker is the first thing you want to set up TLS, because you want to make sure all your client interacting with your broker are in a secure way. So the first thing you need to do is you need to make sure broker is enabling the TLS. So you need to make sure the server side enable the TLS. Let's see. Okay. Actually, let me hide some of these. Uh, Let me hide the proxy function worker, function worker, function worker. Okay. So the first thing is sometimes you actually don't have proxy. That means client talk to broker, client talk proxy. But proxy is just they run the same similar code as broker, so they don't have kind of different settings. They basically just share very similar settings. So the first thing you need to make sure is you need to make sure broker and proxy having TLS enabled. In order to enable TLS, you basically need to configure a few things. The first thing is you need to have the trusted. That the trusted is the basically the public CA certificate that you kind of sharing between your server side components and also client side components. So that is the first thing. You need to have a trust cert, which is the public CA certificate. And the second thing is the key file in the certificate file. Both key file and certificate file is per component. So if you config proxy, you can generate a key file in certificate file for your proxy. And if you config broker, you can just generate the key file in certificate file for your broker. And to give you a quick idea about how it looks like in the Pulsar config, I'm going to show you these. Okay, let's see. Okay. So in Pulsar, there's a file called, proxy, and that is configuring proxy. And you have a config file that is config broker. And if you want to config the enable TLS, you basically just need to config the settings starting with TLS. So you need to provide uh, the first thing is the TLS certificate file, which is the certificate for proxy, and also the key file for generating for proxy. And this the trust cert file is the public cert file that is issued by the public by a certificate authority. So that is the three items you need to config. And in both proxy and broker, you are actually doing a similar thing. So that is the enabling the server to having TLS in place. So similar thing in broker, you can config these three items: the TLS key file, certificate file, and trust file. So once you have that, you need to uh, realize is in proxy, TLS and non-TLS are serving in different parts. So if you want to having the TLS enable, uh, besides setting this TLS setting, you need to specify the broker service port TLS and web service port TLS. So once you enable that, uh, broker would try to use the TLS settings to set up TLS for these two ports. And if in some time you might want to have a non-TLS port for open for internal users, then you can leave this port set. But sometimes if you want to just completely disable non-TLS ports, then you can just setting these two settings to empty. It would disable the non-TLS part on your broker. So that is the broker. Similarly, you can do the same thing for proxy. So sorry, you need to configure the service part TLS to enable TLS, and also if you want the HTTP to be uh, you can configure the web service part TLS to enable the TLS part on your HTTP service. And similarly, you can just unset these two settings to disable non-TLS part. So both the broker and proxy setting are very easy. So once you have this broker and server enable TLS, the next thing you need to do is you need to do this for client, because if you already have TLS and broker enable, uh, TLS enable on both either proxy or broker, then your client need to have the ability to connecting to proxy and broker. So in this way, what you can do is you need to configure the client side settings. And similarly, I think the client setting is much simple. If you just go to this client config, you'll be able to see what it just need is the TLS trusted file path. That is the public. So that is the public cert that issued by the certificate authority. So all you need is just configure these settings. So that is the client side setting, and and once you have the cert in place, what you need to do is when you configure the service URL to be used, you need to configure the web service URL to point to the TLS encrypted part and the broker part to the TLS part. So that is the two settings you need to be carrying on the client side. So then we have this client to proxy or client to broker connection to be encrypted by the by TLS. So you have the client and enable TLS. So the one more thing is if you have proxy enable TLS and you also have broker enable TLS, then you would be thinking, should I enable the TLS connections between proxy and broker? And that is something you can also do is you can enable the TLS for the connection between proxy and the in the broker. So in order to do that, you just need to configure the settings on the proxy side. So there's a setting called TLS enabled. So TLS enabled, with broker, means you're enabling the communication between proxy and the broker. When you enable this, you need to make sure uh, the the broker have the TLS enabled. So once you have this enabled, Pulsar proxy will try to acting as a client talking to the broker. So you have to configure a, a client-side CA to talk to your broker. So that is the another setting. You need to basically set this broker trust cert file path. That means proxy is acting as a broker client to talking to the broker in TLS. So you need to dispute the public CA cert to proxy, so the proxy can use that cert to use that to use that cert file to talk to broker. So that is the encryption between the TLS encryption between proxy and broker. Similarly, since broker might need to talk to a different broker, the broker for geo-replication or for admin request purpose, so the broker also need to talk to the other broker, and within broker config, you can also find the similar setting that's starting with broker client. And the broker client is basically configuring the enable TLS to make sure, okay, when the broker talk to each other, it will use TLS for communication. And the next thing is, because when a broker talking to the other broker, this broker is acting as a client to the other broker. So you need to set the broker, the public CA for this broker client. So you need to also configure this broker client trust search file path, just as how you configure a client. So that is the broker side. So once you have this client setup, proxy setup, and broker setup, you basically have a good have a TLS encrypt cluster between actually between this this component client, proxy, broker, and broker between broker and broker. So that is uh, the basic setup for Pulsar cluster. But sometimes if you are running function worker and you have function worker that is running either setting outside of broker or within broker, that is the most tricky part at this moment, is because uh, in order to provide the flexibility for running functions in different approach, the function worker can be run as part of broker or it can be run outside of broker. So it actually we can start from function worker running outside. So if function worker running outside, in order to secure the connections, you have to, what you can do is, let's see, first thing, you need to enable TLS on function workers. So similarly, it's configuring, you can configure the TLS settings in function worker YAML file, and all the settings start with TLS. So you can configure TLS enable, and then you can configure the TLS key file and TLS certificate file and TLS trust file. So that is the TLS settings. And similarly, you have two ports enabled. You can turn on the worker ports for non-TLS and worker ports TLS for TLS connections. If you setting this to empty, you can disable one of the ports. So that is the function worker. So if you have function worker set up, you need to having the function worker talking to broker, because if the broker is TLS enabled, you need to make sure your function worker talking to broker. Uh, Ideally, it should having a setting called broker client TLS search file, but unfortunately, we don't have this setting. Instead, it's just reusing the TLS search file here for talking to broker. So that means your function worker in broker need to be signed by the same CA. If you don't sign these two components using the same CA, you will have trouble because they are sharing the same settings. And this problem is being addressed in master. I think there's a pull request to separating these two settings. To one is the TLS trust search file for configuring the function worker to enable TLS for its outstanding for its incoming connections, and having a client TLS trust search file for configuring the TLS between function worker and broker. And another thing here is, since proxy might be able to talk to function worker, so with that being said, if you go to proxy, there's no separate setting say I want to talk to function worker using a separate search. It basically only have one setting. It's the broker's client search. So with that being said, in the function worker, when you specify the TLS search file path or TLS key file path, you have to using the same search server search you generating for broker. So basically, function worker to the search file you config need to be same as broker. The reason we design in this way is to allow function worker to simplify running within a broker. So you can run function worker within a broker. Okay, so that is the function worker. And if you run with the function, when you run function worker as part of broker, most of the TLS setting here will not be used anymore, because Pulsar will try to use the TLS settings within broker and override using the broker settings. So that is something you have to keep in mind. If function worker is config running as part of broker, you don't need to config separate TLS settings for function worker. They will just reuse the TLS settings within broker. So that is the TLS part about all the. So far we have been talking about the client, proxy, function worker, broker, and all the components that providing by Pulsar. And the next thing is, if you want to enable uh, the connection between enable TLS for the connection between broker and bookie. So you need to config the TLS for bookies first. And TLS for bookies is you can actually you can go here and try to do the similar thing. It's very similar as you create a CA, and you create a server-side certificate and sign the certificate using the CA. But the different thing here is it doesn't use the perm file. Instead, it's using a key store and trust store. Because using key store and trust store, you can using the same key store and trust store to managing different keys inserts for different components. So you can just follow the instruction to generating this CA insert. And what you can actually config is on the BookKeeper side, everything start with TLS, and the settings you looking for enable TLS on bookies. But one thing you have to realize, Bookie doesn't have a separate part for TLS. It's only using one port for both non-TLS and TLS. And what it does is when it tried to do connecting using TLS, it would do an operation called start TLS. So it promoting a non-TLS connection to a TLS connection. So there's no separate part to enable in order to using TLS. So that is the bookie side. And once you have the bookie side enable about these settings, you need to configure the connection between broker and bookie. So in order to do that, you need to configure the broker configuration to use TLS. So if you go to BookKeeper, then you can see there's a setting called BookKeeper client. Oh, sorry, I'm in wrong file. I need to go to broker config and just go to the settings starting with BookKeeper client. Then you are able to see there are a bunch of the settings about the BookKeeper client. And the one most relevant is sorry, actually, I'm wrong. It should be BookKeeper TLS. So it's all starting from TLS, and you're able to configure different certificate files for configuring the TLS between BookKeeper and the broker, a broker in Bookie. So that is encrypting the connection between broker and Bookie. And the next thing is you need to, if you want to enable the TLS settings on Zookeeper, so what you need to do is you need to enable the settings for Zookeeper. And for Zookeeper, it's very similar. You are using a different part, which is called a secure client part. Uh, but a different thing is you need to load the a different server connection factory, which is called native server connection factory. So it because Zookeeper only enable TLS if you're using native as its connection library, and you need to configure the key store and trust store as system properties. So there's no other way to do that. So basically, what it means, you need to modify the uh, Zookeeper conf to adding a setting to enable the secure client part here. So it will be secure client part here. And once you do that, you need to adding the system properties to when you run Zookeeper. What you can do is Pulsar have bunch of the extra system options called options. So called Pulsar extra options. So you can put these system properties into Pulsar extra options, so that it would use that to load the corresponding key store and trust store. And you have all the instructions available in this Zookeeper SSL user guide. When you configure the server side, the next thing you need to enable is you need to enable the server side configuration. Let me hide list. So when you enable server side is first thing you need to remember, you need to connecting to the server port using the secure port, which is a different port than 2181. With that being said, on the bookkeeper side, you need to update the Zookeeper server to point to the TOS part. And similarly, you need to do the same thing for broker. If you configure the broker to do the similar thing, you need to add that part in Zookeeper server here. And the last thing you need to do is on the proxy side, if you're using Zookeeper server for service discovery, you need to do the same thing. And after that, you need to do the similar thing. You need to configure using the native as the connection. and using the keys, configure the key store and trust store. So that at this moment, you basically configure all the components that is enabled using the TLS. So congratulations if you follow all the instructions and follow step by step to configuring all the components, you would have a cluster that every connection between components are secured by TLS. And that's all the content about today's show. And I have putting up all the links in these show notes, and you can check out these links to know how to configuring how to securing the cluster using TLS. And there are two other topics I might want to cover in the next show is we actually develop a security tool as part of Pulsar control to simplify the process. You can use that tool to generating self signed certificates and for different components. And when you do Kubernetes, when you deploy a cluster on Kubernetes, there are a bunch of options. You can use a cert manager to issue self-signed certificates, or using Let's encrypt to issue a public CA signed certificate. Uh, to automate all these TLS management. And on Kubernetes, you can also using a different approach. You can use Vault to generating CA certs. You can also using Istio to managing all the certs. And I will try to cover those topics in a different show. And that would be all for today's show. And hope you enjoy my presentation today, and hope that give you an idea how to enable TOS on your cluster. And thank you, everyone. Hope you guys have a great afternoon, evening, nights on Friday. Enjoy your weekend, and see you on next episode. Bye bye.